Alright, we're going to go ahead and get started on our next unit here, and our next unit is going to be on solving quadratic equations. And since I'm not going to be able to be here today, I'm going to have you do this as a video lesson. We are going to get two sections done today, so you'll have two separate videos to watch and go over with your classmates as you're going to work together. This video is on an introduction to solving quadratic equations, and we need to first remember what a quadratic equation is. And when we studied polynomials, we said the word quadratic referred to a polynomial equation of degree 2. So we have an example here, x squared plus 7x minus 9 equals 12. We call that a quadratic equation because of this 2 here being the largest exponent in the problem. That makes it a polynomial equation of degree 2. So let's go ahead and start with some basic solving here. Given the equation x squared equals 9, if I just gave you that equation in a general sense, if we think about it like a 6th or 7th grader might think about it, and I just said x squared is saying what number squared gives you 9, most of you would come up with a solution to that. However, most of your solutions are going to be incomplete. I assume most of you can say, oh, 3 squared is 9, because squared means a number times itself, and 3 times 3 is 9. The problem is that solution is incomplete. There are actually 2 solutions to this equation. Because not only is 3 squared 9, but negative 3 squared is also 9. Negative 3 times negative 3 is 9. So we actually have 2 solutions to this equation. Similar to what we did with absolute values, we have a positive and a negative solution in this case, where you have both 3 and negative 3 squared, giving you 9. So how we go about solving this is we look at the fact that when I solve equations, I use inverse operations to solve that equation. And just like an inverse operation you've been doing all year, where we say if I have a plus 7, I subtract 7 to get rid of it, we're going to use the opposite of a square to get rid of x squared. So I'm going to take the square root on both sides, because by taking the square root to both sides, I eliminate x squared and it becomes just x, because the square root is the opposite of a square. And then we just need to remember this portion. Whenever you are solving an equation and you take a square root, you're going to come out with 2 separate solutions. That square root requires us to say both a positive and a negative 3. And the reason why is what we talked about before, that both 3 squared and negative 3 squared are 9. So when we're solving equations using square roots, we need to make sure we're always giving a positive and a negative solution. So the square root method is our first method we're going to use to solve quadratic equations. And in order to do the square root method, we have a couple little things we've got to be sure of. First of all, our first little point here is that we can solve for x squared just like you would solve for x in any other equation. Once you get x squared by itself, you take the square root of both sides. However, this method is somewhat limited in the way that it only works when there is no x term in the equation. What I mean by that is we can use the square root method to solve this one because I have just an x squared term and no x term in the equation. I can solve that by getting rid of the minus 10, getting rid of the times 4, and taking the square root. However, the square root method doesn't work for this equation because of that x term. So therefore the square root method is one that people really like because it's very similar to what we've done in the past. However, it frustrates people a little bit because it doesn't work all the time. It's a nice method, but not one we can use for every quadratic equation. Alright, our first example of our square root method is very straightforward here. We have an equation like x squared minus 8 equals 17, and we're asked to solve that. Well, we said when we're doing the square root method, we solve it just like a traditional equation. I solve for x squared just like I would solve for x. So to get rid of minus 8, I'm going to add 8 to both sides, which leaves me with x squared equals 25. Then I have an x squared by itself. This is my square root method situation where in order to get rid of the square, I need to take the square root of both sides. Now the square root of 25 is 5, but we talked about the square root method. Anytime you take a square root, we need to acknowledge the fact that both 5 squared and negative 5 squared are 25. So therefore, anytime we get rid of a square with the square root, we get our plus or minus in our answer. And remember what that plus or minus means. It means there's two different answers here. I can write them as x equals 5 and x equals negative 5, or I can use the plus or. So let's take a minute and look at our non-perfect square problem here. If I have an equation like 3x squared plus 12 equals 84, I'm going to solve that, again, by doing all the traditional solving steps. 3x squared equals 72. Divide by 3. X squared equals 24. This is just the solving stuff we've always done to get x by itself. Now, to get rid of the square, I take a square root. My answer is going to be x equals plus or minus something. However, 24 is not a perfect square. It doesn't have a square root. Now, we are not going to use decimals. Again, I stress that. We are not going to use decimals. If you put a decimal answer from your calculator on a test, you will lose a point. Because we do our exact square roots by doing our factor trees on 24, and we get our answer of 2 radical 6. So we always put our answer in simplest radical form by using our factor tree. And so this is the square root method. Hopefully it's pretty straightforward. It's not too confusing at this point. All right, we have two other quick examples to look at here. This one is one where we're going to get a fraction answer. So let's go ahead and do the work, just our traditional work. Subtract 12, 9x squared equals 25, and I divide by 9, giving me x squared equals 25 ninths. Now, in this course, again, we've talked about we don't use decimals very often in algebra. We leave that answer in our fraction form. And this is actually going to be easier with a fraction, because you'll notice when I go to take the square root of both sides, I have a fraction that's actually a perfect square. I took a square root, so I'm always going to have a plus or minus. And the square root of 25 ninths is the same as taking the square root of 25, which is 5, and the square root of 9, which is 3. So my answer is plus or minus 5/3. And our last thing we need to look at is our special cases, where if I want to solve these equations, case 1, I'm going to go ahead and do my solving steps. 3x squared equals negative 9. I divide by 3. X squared equals negative 3. When I go to take a square root, I have a problem. Because I take a square root of negative 3. Well, that's an impossible situation. We've talked about square roots and how you can't take a square root of a negative number. And so as far as this course goes, we're going to simply say that's no solution, because you can't take a square root of negative 3. There's no number times itself that'll ever give you a negative. So for the purposes of this course, we're going to call that no solution. Our second case over here, when I subtract 12 from both sides, I get x squared equals 0. When I take a square root, the square root of 0 is 0. Now you notice I didn't put a plus or minus in front of that because there's no such thing as negative 0. So these two special cases give us our only situations where you're not going to get two answers. A quadratic will always give you two solutions unless you're taking a square root of a negative number, which in this course we're going to call no solution, or a square root of 0, which simply leaves you with 0. So I'm going to have you go ahead and get to work on your first worksheet. After you've finished that or gotten a good start on that, we do have another video over the zero product property that you'll want to come back to and watch that video. If you'd like to watch that first and get notes down, that's fine. Then you'll have the two worksheets to work on.